Hi everyone, Assalamualaikum. In this video, we will continue with integration by trigonometric substitution. Now we look at example 2 with radical containing square root of a squared plus x squared, and we take x equals to a tangent theta, right? Evaluate integration of x over square root of 9 plus x squared dx using trigonometric substitution. Right, the solutions are as follows. Okay. Using trigonometric substitution, step 1, we take x equals to 3 tangent theta. Why we take x equals to 3 tangent theta? From the previous video, we have been discussed this formula. Okay, we have three types of radical. Number 1, square root of a squared minus x squared. We discussed in example 1 in the previous video. Number 2, we have radical square root of a squared plus x squared in this example. Alright, because in between is plus now. Okay, so we take substitution x equals to a tangent theta. Right? Right, so now we need to find the value of a. So how to find the value of a? From the given question here, we have radical square root of 9 plus x squared. And when we compare from types of radical square root of a squared plus x squared, from here, we can rewrite square root of 9 plus x squared equals to square root of 3 squared plus x squared. And when we compare from here, okay, our a is a constant 3, right? Then we replace in a here, right? So that's why we take x equals to 3 tangent theta, right? And after that, since we have term containing x squared in radical here, okay, so step 2, we need to find x squared, okay? So by squaring on both sides from step 1, so we have x squared equals to 3 squared equals to 9, and then tangent squared theta, right? And after that, step 3, we need to differentiate from step 1, okay? When we differentiate x with respect to theta, the symbol is dx over d theta. But we need to write dx as a subject. So we bring over d theta from left hand side here, we bring to right hand side. So we get multiply by d theta here. And when we differentiate 3 tangent theta, we still have constant 3 in front. And then when we differentiate tangent theta from this formula, it is equals to sec squared theta. Right? When we differentiate tangent theta with respect to theta. So the answer equals to sec squared theta. So that's why we get this. Right? And after that, step 4, we need to eliminate radical from the given question. From the given question, we have radical 9 plus x squared. Right? We can write square root of 9 plus, we replace x squared from step 2 equals to 9 tangent squared theta from here, right? And then now we have same constant 9 and 9 here, so we can factorize constant 9. And in bracket, we can write 1 plus tangent squared theta. Alright, so that when we expand, we will get back the function from left hand side here. Alright, and then from here, we can write square root of 9, and then we write 1 plus tangent squared theta equals to sec squared theta from this identity. Alright, 1 plus tangent squared theta equals to sec squared theta. Right? And after that, we can simplify square root of 9 equals to 3 and square root of sec squared theta equals to sec theta. Right? And then, from the given radical here, square root of 9 plus x squared, from here, we have term containing radical and no trigonometric function. Okay? After we simplify using trigo identity, now we have no more radical but with trigonometric function. Right? Right, after that, we substitute step 1, 2, 3, and 4 into the given question. Right? From the given question, we have integration of x over square root of 9 plus x squared dx. Right? After we substitute step 1, 2, 3, and 4, we get this. Right? Now, let me check one by one. Okay? We replace x equals to 3 tangent theta from here. Right? And then we replace dx equals to 3 sec squared theta d theta from here. Right? And we replace square root of 9 plus x squared equals to 3 sec theta from here. Right? From here. Alright, after we substitute step 1, 2, 3, and 4 into the given question, now we have term containing theta and trigo and no more variable x. But from the original question, we are given in terms of variable x and with radical. Right? And from here, after we substitute, we can simplify. So we can simplify 3, constant 3 and denominator 3 here. And then we can simplify squared here with sec theta. Okay. And we can move out constant 3 from integration sign. So after we simplify, we get 3. And then integration of, we still have sec to the power of 1 theta. And then tangent theta, and then d theta. Right? And from here, now we have term containing theta and no more variable x. Okay? So we can integrate the trigonometric function with respect to theta. Alright? When we integrate sec theta tangent theta d theta, the answer equals to sec theta. We still have constant 3 here. Why we get this answer? Okay, from appendix in final exam, we can refer formula number 7. When we integrate sec ax tangent ax dx, the answer equals to 1 over a sec ax plus c. Right? So from here, if we replace a equals to 1, let's say. Okay, so we have integration of sec x tangent x dx equals to 1 over a. So from here, we have 1 over 1, let's say. So we have 1, no need to write, and then sec x plus c. Okay, so that's why when we integrate sec theta tangent theta d theta, the answer equals to sec theta plus c. This is formula in terms of variable x. So if we have term containing theta, so we just replace variable x by theta. Alright? Okay, now we have successfully integrate. However, the original question was given in terms of variable x, and there was no trigonometric function. So, it is impossible to get answers in terms of variable theta and trigonometric function. Right? So, what should we do? Okay. From the previous slide, we get this. Right? However, the original question was given in terms of variable x, and there was no trigo function. So, it is impossible to get the answer in terms of theta and trigo function. Alright? So, we still not finish our solution. And we can name it as equation 1. Right? So, the next step, we need to replace sec theta in terms of variable x by using triangle method. Right? Alright. To use triangle method, first, we use the first step. Okay, from the first step in the previous slide, we have x equals to 3 tangent theta, right? Then we write tangent theta as a subject. We replace 3 to left-hand side, so we get x over 3, right? And then we can draw a right angle triangle with angle theta, opposite x, and adjacent 3, because tangent theta equals to opposite over adjacent, right? And after that, we use Pythagoras theorem to find the third side, right? After we use Pythagoras theorem, so we get this, square root of 3 squared plus x squared. So we have square root of 9 plus x squared, right? Now, we have square root of 9 plus x squared, which is same as the radical given in the question. So, it means that our substitution from step 1, x equals to 3 tangent theta is correct. Right? That's the way how we check whether we choose the correct formula in step 1. Because step 1 is very important. Alright? Alright. And then we can replace sec theta. But before that, since sec theta is a reciprocal function for cos theta, first we find cos theta, right? Alright, cos theta equals to adjacent over hypotenuse. So we can write cos theta equals to 3 over square root of 9 plus x squared. Okay, from cos theta here, we can find sec theta. Okay, we just exchange numerator and denominator from cos theta. So we get sec theta equals to square root of 9 plus x squared over 3. Okay, so after that, we substitute sec theta equals to square root of 9 plus x squared over 3 into equation 1 here. Right? So after we substitute, from the given question, integration of x over square root of 9 plus x squared dx. And then it is equals to, we still have constant 3 in front. And then we replace sec theta equals to square root of 9 plus x squared over 3 from here. Right? And then we have plus c at the back. Okay? After that, we can simplify constant 3 and denominator 3 here. And after we simplify, the final answer equals to square root of 9 plus x squared and then plus c. So this is the final answer after we integrate this. Okay? Since the original question was given in terms of variable x and radical, so it is logic to have the final answer in terms of variable x with radical also. Alright? Alright, for this question, we also can integrate using U substitution. Right? Because we have numerator x to the power of 1. And the function inside square root in denominator, we have term containing x squared. Okay? Where we can relate with derivative. Okay? So every time when we can relate with derivative, we can integrate using U substitution. Because when we use U substitution, we have derivative part and integration part. Under derivative part, we need to differentiate. And under integration part, we need to integrate. Right? And when we use U substitution, first step, we need to identify the suitable function as U. Alright. From here, first we can move up square root of 9 plus x squared. Okay, square root of 9 plus x squared means 9 plus x squared bracket to the power of positive half. And when we move up using the properties of indices, so we have to the power of negative half. Right? And then from here, we cannot expand x in bracket because we have bracket to the power of negative half. Okay, so we can use U substitution. Okay, we choose U equals to 9 plus x squared. And then after we choose U, we need to differentiate. So we get du over dx equals to 2x. And after that, we write dx as a subject. Right? So we have dx equals to du over 2x. And next, we need to replace into the original question here. Okay, we still have x, and then we replace the function in bracket equals to u, and then to the power of negative half, and we replace dx equals to du over 2x. After that, we can simplify whatever x here and denominator x here. Okay, and at the same time, we can move out denominator 2 from integration sign. So after we move out, so we get half in front here. Remember, we only can move out constant from integration sign and never move out variable such as x, u, and so on from integration sign. Alright? So now we have half integration of u to the power of negative half du. So negative half here means n not equals to negative 1. So when n not equals to negative 1, when we integrate, we need to use power rule. Alright, power rule for integration means we add 1 from the original power, and then we divide by n plus 1. Okay, we still have constant half and then times. When we integrate, no more integration sign, and then after we add 1 from negative half, so we have u to the power of positive half. And n plus 1 means negative half plus 1 equals to positive half. We have constant half in denominator, and we have constant half in front here, so we can simplify. So after that, we get u to the power of half plus c. And u to the power of half means square root of u plus c. And final step, when we use u substitution, we need to replace u in terms of variable x. So we get square root of 9 plus x squared plus c. So this is the final answer when we integrate using u substitution. And this is the final answer when we integrate using trigonometric substitutions. Okay, from here, we can see that the answers are equal, right? Because both methods are correct, right? Mathematics is magic. When the method is logic, the answer should be equal, right? Got it? Coming up next, still under integration by trigonometric substitution, We will discuss example 3 with radical square root of x squared minus a squared. If you like this video, you can subscribe. Thank you for watching. Stay tuned. Bye. Assalamualaikum.